So we've got y equals the quantity x squared plus 4 times the quantity x minus 1. Now, if you want to get the equation of the tangent, based on the responses you guys gave, you know that you need the derivative, which that shows good growth. That's what we talked about Friday. The only problem here, if I can call it a problem, is that this function is a product. It's a product. Okay, now if you're like, yeah, so what's the big deal? On Friday, we didn't learn how to do the derivative of a product. We learned how to do the derivative of a polynomial. Now, a polynomial has to be separated with plus and minus signs. Can you take this product and can you turn it into a polynomial? Yes is the right answer. You should say, yes, I can turn that into a polynomial. Okay, now what's happening here is we're doing algebra before calculus, as I like to say. And maybe you're thinking it's like the FOIL method. But seriously, now you know how to do the derivative of an x cubed minus an x squared plus a 4x minus 4. Now, see if you can do the derivative, but see if you can find the equation of the tangent. You know, what's that all about? Good. Good. The derivatives look good. Once you have the derivative, keep thinking, like, what is this equation of the tangent? Think about what Colton said about this being a formula. You guys are making a formula right now. Make sure you have the correct derivative. Just double check. It's 3x squared minus 2x plus 4. 3x squared minus 2x plus 4. Now remember, that thing's a formula, so you plug into it. You plug into it. But don't stop there. You're trying to get the equation of a tangent. Good, but don't stop there. But that's really good. You're still trying to get an equation. You have the slope. So now what? Let me just kind of be a step behind you, because obviously we don't want a mistake in here to mess up your next thought. Be careful. I think if some of us are honest, and I hate when this happens, you do too probably, but sometimes we're still making just arithmetic mistakes. This is not 9 squared, or this is not 3 squared. This is 3 times 1 squared. This is 3 minus 2 plus 4. Okay, make sure you do the order of operations. So you don't get 9, but you get 3 minus 2 plus 4. Now, as I've said to some of you, don't stop there. The slope is 5. What's this equation of the tangent language? And as a little hint, when you get your final answer, you can graph if you're kind of just hanging out, you actually could graph something and know that you're exactly right. There you go. Okay, now the good news is you don't have to do that because you have this new method. You don't have to use limits because you have a derivative. You have your slope, but you still want to do something with that slope of 5. Good, you're on the right track, but you get a different y-intercept. You're definitely on the right track. Now, as kind of a general hint to those that are kind of like, what else do I do? You have to think y equals mx plus b. You have to think y equals mx plus b. Okay, because if you're trying to get an equation of a tangent line, you need a slope, which we spend a lot of time, or we spent calculus finding, so we got the slope of 5, but you continue to think y equals mx plus b, so you have to get a y-intercept. Make sure that you process that a little bit, and then we'll see if you get the final answer. Remember, you could make a little sketch. It's not really the greatest sketch ever, but you could make a sketch that would support all your hard work. What's kind of the missing nugget here to get this y-intercept? Did you were you one of those people that like, yeah, I realized I need to do this?
You need to figure out that point or something.
It's very well said. You need to find this point. Okay, there's a lot of plugging around. There's a lot of plugging in. There's a lot of numbers going around here, but where do you plug in 1 to get the point? Yeah. So if you want to plug the number 1 into the x cubed minus x squared plus 4x minus 4, or if you want to plug it into the original, but that's correct. You plug it in and you get your y value. It's interesting. It turns out to be 0. When you plug in 1, you get y equals 0. Make sure that you think about that. Don't just write it down. We plugged in the number 1 so that we could basically get the point. All right, so b equals negative 5, a little bit of algebra, so we can have our tangent. Now that problem should sound like something you did last chapter, but we did that with limits in the last chapter. And I know it was pretty fun, right? Doing that whole limit thing. But now you kind of have like a new and improved method. It's called a derivative. Around Christmas time, we even sing some songs about derivatives, but we're not there yet. We're not at Christmas, and we're not ready to kind of enjoy all the fun with that. Now, if you graph this, again, maybe I'll ask you to do it in the assignment, but it does show that you can make a little connection here between the original, make sure you graph the original equation, and then you graph your tangent. Don't graph the derivative. That's actually something we'll do a little later, and that's a whole different ballgame. But graph the original equation and graph the tangent line. Okay, it's not really that pretty because everything's all sort of squeezed between a couple x values. I'm going to zoom in so my graph gets a little curvy. So what I did there is I zoomed in around -3 to 3, and now my graph at least looks like it's got a tangent. By the way, at 1, 0. So it should kind of look like that's the place of contact. That's a good problem, because what we're going to do now is we're going to learn more rules. Remember, rules don't have to be like negative. They're actually going to help you. But we're going to learn rules, but you can always go back and do one of these problems. What's one of these problems? An equation of a tangent. I want you just to think about that, the steps we went through one more time, because it'll always be the same steps, even if we get more rules. What kind of rules? What do you mean more rules? Remember I said that the problem that I gave you was a product? Okay, the original problem up here was a product. We actually can do the derivative of a product. We just have to use the product rule. Okay, we have to use the product rule. Now be careful if you're like, yeah, but I don't need that, right? I could turn it into a polynomial. Trust me, you'll need it. But right now we're going to show you another way to get the same answer. It's the product rule. Now the product rule is how you do the derivative of a product of uv. Now I want you to understand my notation here, because you're going to see it a lot. U and v just represent the two, I'll call them things, or the two functions that you're multiplying together. So u and v are just the two things that you're multiplying together. That d dx that you see in front of it, that's also notation. I don't want you to get blown away by it. It just stands for the derivative. If you're like, why is it not dy dx? I thought it was dy. Okay, because it's not the letter y right now. It's uv. So it's kind of like duv dx. You don't have to get too hung up with that. It's just some notation for the derivative. Okay, it goes like this. You take u and you multiply it by the derivative of v. So we call it u dv dx. That would be u times the derivative of v plus v times the derivative of u. I'm trying to get every color on the screen. So we have v times the derivative of u, and that's in yellow. Now, this is good. It's important that you see this. Most students, and even myself, will run through their brain kind of this little phrase where they'll say first times the derivative of the second. So that's the u dv. That's the first times the derivative of the second plus the second times the derivative of the first. And I encourage you to say that to yourself as you're doing derivatives. I'll say it so you understand what I mean. Let's try it for this original product. Okay, let's try the product rule for this original product. Now remember, try not to say, yeah, but I don't need this, Mr. Naylor. Okay, there's a reason you're learning this, and trust me, you'll need it, even if it seems a little tricky the first time. This is all I mean by u and v. X squared plus 4 is u. It's like the first. And then x minus 1 is the v. It's like the second. Ready? We're going to use the product rule. Okay, so the first. Now, the first implies that you just copy it down. Okay, it basically doesn't get changed. So x squared plus 4 is the first times the derivative of the second. Now you should be thinking to yourself, how do you do the derivative of x minus 1? Okay, now don't overthink it, but try to remember from Friday the derivative of x. Well, that's always going to be 1 Now remember, the reason the derivative of x is 1 is because that's the slope of x, or you could also think about the exponent of 1 coming down in front, and then you get an exponent of 0. But bottom line is it's 1. How about the derivative of minus 1? And again, remember from Friday that is 0. So basically, the derivative of the second is 1. Plus, according to the product rule, the second, so I copy down x minus 1, the second, times the derivative of the first. Now, the derivative of the first, you should be using the power rule on x squared. The power rule on x squared would bring the exponent down, and you get a nice little 2x. The derivative of 4 is, of course, 0. Now, everything we did is right, but since we did calculus before algebra, now we have to do the algebra and see if there's anything that needs simplified. So a little bit of simple distributing, a little bit of simple combining like terms. We're going to end up with an x squared plus a 2x squared, which lo and behold is 3x squared. And then we'll end up with the other terms, minus 2x plus 4, exactly what we found over here. Okay, so the product rule. See, I wouldn't fool you, okay? It works. Try one and try it with the product rule. What I'm suggesting is think of this as a first and a second. Even though you could do the distributive property right now, I encourage you to try the product rule. So you want to think of this as a UV. We have a 4x squared and then a quantity 2x minus 3. Now, after you do the calculus, if there's any like terms, if there's any simplifying, see if you can do any further steps. You want to you're doing algebra before calculus. You want to try to basically do the derivative using the rule. Okay, so you're going to write down the first, and then you're going to do the derivative of the second. So how'd you do? The first, that'd be your 4x squared, times the derivative of the second. The derivative of 2x is 2. The derivative of minus 3 just disappears. So that's the first derivative of the second, plus the second. So I'm going to write down the second, times the derivative of 4x squared. Remember, bring the 2 down. You get 8x to the first power. You subtract and get to the first power. Okay, so just plain and simple, there's the product rule. But you should be aware that there are going to be some like terms. There's going to be some simplifying, and you need to do that. Ultimately, 8x squared and 16x squared give us a 24x squared. 24x squared minus 24x. Now, there's going to be a problem in your assignment where it's going to say, they don't say it in these words, but this is what they mean. They're going to say, do algebra before calculus. So that means you're going to turn it into a polynomial. And then they're going to say, do calculus before algebra. That means you're going to do the product rule. And you're supposed to get the same answer both times. So when you do that in your assignment, you want to do it both ways. Okay. That's the horn. Remember, there's no warning this time. There's no warning.